Hello everyone. Today I'm going to be talking about the throughput capacity. So how do you decide which the throughput capacity you are going to use for your Dynamodb instance? So you're about to provision a table and you want to know what throughput capacity, the read capacity you need and the write capacity you need to provision for your Dynamodb. Now, the amount of capacity that you provision depends on how many reads you are trying to how many read operations you are trying to execute per second, and also how many write operations you are trying to read per second. Now, before I actually go into this, I would like to explain something. I would like to explain eventual consistency and strong consistency, because these two kind of consistency also determine your throughput capacity provisioning. What is eventual consistency? Eventual consistency is a type of read consistency in which there is no guarantee that you have the latest update. Let me give an example. Anytime you create a DynamoDB table, you most of the time you have like about 3 copies in different AZ. Now, this is table 1, this is copy 1 of the table, this is copy 2 of the table, and copy 3 of the table. Now, let's say we have an item in the table. Let's call the item A, right? Anytime you write A to the table, at first, all the 3 copies are going to have A. Now, let's say later you updated A to B. Now, what happened is one of the copy gets written to first. Let's say copy 2 gets written to first. And after you write, you read. This is where consistency comes in. If you choose eventual consistency, that means DynamoDB tries to read from any of this copy. So it will try to read from copy 1 or copy 2 or copy 3 at random. So if it reads from copy 2, you get B. But if it reads from copy 1, you get A. You see? So eventual consistency does not guarantee that you have the latest update. But strong consistency guarantees that you are actually working with the latest update. Hope that explains both kinds of read consistency. Now, based on AWS specification, each read consistency unit, or each RCU, right? For if you are actually operating under eventual consistency, you can perform 2 reads per second. And each read can get at most 4 kilobyte item. So if you have one RCU and you can perform 2 reads per second, that means at most you can only get 8 kilobytes of item per second, as you can see from this calculation. Now, if we are operating under strong consistency, for strong consistency, one RCU can only read 1 item per second because it needs to make sure it's getting the latest updates. Since it only reads 1 item per second, that means it can only read 4 kilobytes of item per second. Now, let's give an example. I'm trying to provision a table, and from this table, I'm going to be reading 180 item per second, right? So this is an example. I'm going to be reading 180 items per second, and each of these items is 3 kilobytes, right? Now, since this is a strong consistency, we can only read 4 kilobytes per RCU. So the next thing you need to decide is how many RCU do you need to read 1 item which is of size 3 kilobytes. Remember, One RCU with strong consistency can only read 4 kilobytes per second. Therefore, if each item is 3 kilobytes, one RCU, how many RCU do I need? I just need 3 kilobytes divided by 4 kilobytes, and you are going to, and that should give you 0.75. So you simply round that up to 1. And how many items? So I need one RCU to read each item. Since we have 80 items that we are trying to read per second, so therefore you need 1 times 80. You need 80 RCU, right? You need 80 RCUs to read these items. Now let's say we are actually operating under eventual consistency. In eventual consistency, right? How many items do we need? Eventual consistency allows you to read 80 kilobytes per second. So this is going to be 80, right? So you see, you round that also up, which is going to give you 1. So you still need 80 RCU, right? Now, that is how you calculate your read consistency. Let's go to write consistency. With one write with one WCU, you can only read one item per second. You can only write one item per second, and the max size of that item is 1 kilobyte. So that's the max size of the item that you can write with one WCU. Now in this case, we are trying to write 100 items per second, and each of those items is 512 bytes. That is 0.512 kilobytes. And remember, we can only write 1 kilobyte with one WCU. So we need to get how many WCU do we need for each item we are trying to write. So we just need 1 if you calculate this. And how many are we trying to read? Sorry, how many are we trying to write? Which is 100, right? So you simply multiply this by 100, and that will give you 100. So you need 100 WCU. You need to provision 100 WCU. All right. So these are very simple examples. Now let's move on to a practical situation. This question, I actually got it from one of AWS certification exam, which is you have a motion sensor which write. I believe this should be read or write. This should be read instead of write, which reads 600 items of data every minute. Each item consists of 5 kilobytes. Your application uses strong consistency rates. What should you set your read throughput to? So we are trying to calculate how many RCU do we need in this situation. Just like I said before, you need to know how many RCU you need for each item. Since we are dealing with a strong consistency, we can only read a max of 4 kilobytes with one RCU. But each of our items is 5 kilobytes. So to get how many RCU we need for each item, we simply divide 5 kilobytes divided by 4 kilobytes. And that will give us what? 2. But remember, they said we are trying to write 600 items per minute. So you simply convert that to how many items are we trying to write per second, which is going to be 600 divided by 60, right? And that is what? 10. So therefore, the number of RCU that you need is, you need 2 RCU to read each item, and we are trying to read 10 items per second. So therefore, we need to provision 20 RCU. So it's a very simple, I know it's kind of confusing, but if you go through this explanation again and try to solve it yourself, it should give you a better understanding. And also you can go to AWS page, for more explanation, and look online for better tutorial also if you can find one. Thank you very much.